Okay, we're off. So we're on page 5. We're going to kind of talk again about the graph for a minute, just because we have to create an inverse, right? So this is our normal cosine function, which is just sine shifted to the left, pi over 2. It's going to fail the horizontal line test, right? Just like sine did. So we have to slice it. We're going to cut it. Okay, so we want to stay around the origin. All right. And then we want as big of a piece as possible that will pass the horizontal line test. Turns out cosine is just really fantastic. I can go all the way to pi. Look at there. And there's my little chunk that I'm going to cut out from 0 to pi that's going to pass the horizontal line test. If I go any further, it curves back on itself and it fails. If I go any further this way, the same thing. But look how nice cosine is. I don't have any negative values. I don't have any of that negative, weird quadrant 4 nonsense, right? So if this is going to be my nice little area here that I have found, think about the unit circle. From 0 to pi is located where? Here, all the way to here. So I'm in quadrants 1 and 2 for inverse cosine. If I need my cosine positive, I'm in quadrant 1. If I need my cosine negative, I'm in quadrant 2. And the beauty of it is, to get to quadrant 2, I just go through quadrant 1. I don't have any of that lava nonsense where I got to hop around in a weird way, right? Okay, so here's the domain for the restricted cosine, 0 to pi. Here's the domain for the restricted range, the range for the restricted cosine, okay? So how are we going to remember this? Well, remember, sine is over here on the side. Cosine is going to be on top like a crown, okay? Cosine crown, you're on the top, quadrants 1 and 2. Sine, you're over on the side, 1 and 4. Okay, and those are the only options you ever have. Side, or crown. You're never down there in 3, okay? All right, so here's our nice little explicit version where we just say, okay, the inverse is of cosine x. Then if we rearrange it, some of you like to rearrange it. There's your little rearranged version. Here's our new domain. Here's our new range, okay? We also talked a little bit about the fact that it would reflect over y equals x. So if this is y equals x, right? And this is your cosine right here. This is the original cosine, okay? If I reflect it over there, you're gonna get, I'm gonna mess this up, like that, right? You're just flipping it over there. This is the reflected version of it over there, okay? So if you were to fold your paper on that diagonal line, that's how you get it over there, okay? All right, let's jump right in here then. Okay, so down here at the bottom, we have our first little problem. Okay, I'm gonna try to squeeze this in here too, if we can. Yeah, I think everybody on both screens can see that. Okay, so remember, really the only thing you need to check is that this is between -1 and 1, and it is, okay? Then you're gonna look in quadrants 1 and quadrant 2 to find that value. So I'm looking right here in my unit circle. I'm looking for cosine, which is x, to be √2/2. Here it is, -√2/2. My value is 3 pi over 4. There's my answer. Okay, now we didn't write the implicit and the explicit version, so if you like it, if you like to do that, remember you can write it like this, which is what they gave you, and set it equal to y. Then if you want to, you can flip these, switch them, and get the cosine of some y equals negative root of 2 over 2. And then you can find what that y is. And in that case, it's 3 pi over 4. Some students like that. It makes a little more sense to them. Okay. All right. So with inverse sine, we had these 9 choices. With cosine, inverse cosine, now your 9 choices are here. Okay. Those angles are your 9 choices. Okay, here we go. 3 more of these and we'll do some composites. Everybody okay so far? Inverse cosine, not that bad. Just working backwards. So in this case, remember the first thing we're going to check, does it fall between -1 and 1? Because that's the domain. We have to know, does it fall between -1 and 1? If it does, we keep going. Okay. All right, so up here we have negative root of 3 over 2. That falls within there. If you're not sure if it does, put it in your calculator. It'll give you a decimal, and then sure enough, it falls in there, so you're good. Okay, let me scoot down. Okay, so we can set this little guy equal to y. We can rearrange him if we want with a plain old cosine so that we're looking for the angle that equals negative root of 3 over 2, and we have to stay up here. Okay, so where's x, negative root of 3 over 2? Right here, 5 pi over 6. That's what our answer would be. Okay. All right, let's look at C. Okay, so remember, we need to be between -1 and 1. No, I already see some head shaking. The inverse cosine of 2, that doesn't exist. I mean, you know, that's way too big. So our answer is simply going to be undefined. The reason it's undefined, because this is bigger than our domain. Okay, it's too big. All right, come down to the next one, 0. That's in our domain. It's between -1 and 1. Okay, so if we want to, we can rewrite it. Just set it equal to y. Take the inverse off, flip those 2 values. Okay, we have 9 choices. Okay, cosine is x. So we're coming here looking for x. There we go. Our answer is going to be pi over 2. Okay. How's everybody with inverse cosine? Pretty nice, huh? You don't have to deal with those negative angles down there in quadrant 4. Okay. All right. Any questions on him? Sound good? All right. Let's talk about his composites. His composites are even easier. They're even easier. Okay. So remember, when a function and its specific inverse are next to each other in a composite, they cancel out to the value that's there. Your job is to figure out, is that value valid? Is that value where it's supposed to be? If it's not, then we need to think about it a little bit. So remember, there are choices here. If regular old cosine is inside, then we need to make sure we're in quadrants 1 and 4. If inverse cosine is inside, we're looking at a domain between -1 and 1. Now, when inverse cosine is inside, it's either yes or no. It's very black and white. You're either between -1 and 1 or you're undefined. Those are the 2 choices. You can't have it both ways. If regular cosine is inside, we have some options. We can relocate our angle into one of these quadrants to make it work. Oh, guys, just sit there and let me write anything. I need a little assistance today, apparently. Okay, I know, Ish, I'm letting the family down. Okay, quadrant 1 and 2, that's our cosine. Okay, so let's go over here to B and D first, because that's the easy ones. When you see the inverse inside, those are the great ones. It's either the value or it's undefined. Okay, here's our first value, -0.4. Is that between -1 and 1? Yeah. That's our answer. Awesome. Okay, let's go down to D. Pi. Is pi between -1 and 1? No, how do you know it's not? Yeah, look at you. So pi is that 3.1416, blah, 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 goes on forever. If you're not sure what it is, put it in your calculator. Just hit the pi button, hit enter, and it'll tell you that's definitely bigger than 1. So it's undefined. These are very black and white. There is no in between. You're either it or you're not. Okay, here's the ones where we have to think about relocation. Okay, so if we're in quadrant 1, let's kind of break this down the way that we did sine. Okay, so if your angle's in quadrant 1, you're good to go. It's that value. Okay, if your angle's in quadrant 2, you're good to go because that's also valid for cosine. Our problems lie in quadrant 3 and 4. That's when we're going to need a reference angle. Now, we can go ahead and list how to find the reference angle, which is, for quad, don't write this down because it'll make it a little more complicated. But remember, quadrant 3 said that we would do our angle minus pi. Quadrant 4 said it would be 2 pi minus the angle, okay? But cosine does something weird. Cosine, when their numbers, when their angles are in quadrant 3 and 4, they don't go through quadrant 1 and 2 to get there. So we actually can't use those. They go the other direction and give you the negative angle. So they're going to give you a negative angle in quadrant 4, a negative angle in quadrant 3, which sounds horrible, but actually fantastic because all you're going to do is make them positive. Now, there's real math behind that. I didn't make that up. We're going to look at that. Okay. But it's fantastic. Okay. All right. So here we go. Let's look at the first one. Pi over 12. Where do we think pi over 12 is? That's quadrant 1. Anything where you just have 1 pi over a number is quadrant 1. Like pi over 3, pi over 2, or not, pi over 4, pi over 6. So he's quadrant 1. Fantastic. There's my answer. Remember, it's just exactly what the value is. All right, let's look at C. Now we have an issue. -2 pi over 3. Okay, where in the world is -2 pi over 3? Well, if you go to your unit circle, he's actually +2 pi over 3 is here. It's 120 degrees. So -2 pi over 3, if we go the opposite 120 degrees or -2 pi over 3, what quadrant do we end up in? In quadrant 3. I'm not allowed to be there, right? Everybody agree with that? Okay, so normally if I'm in quadrant 3, I would take my angle minus pi. But if you take a negative angle minus pi, you're just going to get a bigger negative angle. You're not going to get a reference angle, right? So where do we think, let's think about this for a minute. Quadrant 3, is cosine positive or negative here? Cosine is negative in quadrant 3. So if I'm going to relocate him, do I need to relocate him to quadrant 1 or quadrant 2? Quadrant 2. Okay, so if I make him positive 2 pi over 3, where does that relocate him? Quadrant 2, exactly where I want him, where cosine's also going to be negative. So that's why if you're in 3 or 4, just make those angles positive. It's going to come out exactly the same.
So if you have cosine in quadrant 4, you would relocate it to quadrant 1?
Mm-hmm. But you could just add it. Just make it positive. Just change it. Yeah. Okay. All right. Is everybody okay with that? I know that was super weird. You're down here in quadrant 3. Cosine's negative. You want to relocate to quadrant 2. But if you just take the positive version of that, then you're in quadrant 2, right where you want to be. It works out great. Just make it positive. All right. Let's try this page. Okay. Here we go. All right, 8 pi over 9. I need to know what quadrant we're in because I want to follow those little rules. Not sure where he is. We're going to use pi as the placeholder. So if I change pi to something over 9, pi is actually 9 pi over 9. Okay, that's what pi would be. So is 8 pi over 9 in quadrant 2 or quadrant 3? 2. Am I allowed to be in quadrant 2? Sure, you're done. Okay, so if you're quadrant 1, you're good. If you're quadrant 2, you're good. If you're quadrant 3 or quadrant 4, you're just going to take the positive version of the angles for cosine. Okay, let's try, let's skip F and come back in just a second. Let's go to G. Okay. Do I want to do G? Nope, I want to go down here to B, H, and I. We're going to skip those and come back, and you're going to need to fix these dudes because I wrote them wrong. I thought I had corrected them, and I corrected them the wrong way. So what I want is the inverse on the outside, and I want plain old cosine on the inside. I want to keep practicing what we're practicing with the quadrants, okay? So correct that for me. All right, well, I automatically see negative angles. So actually the answer to this is going to be 6 pi over 7. Answer to this is going to be 7 pi over 10. But let's look at it and see why that is, right? Okay, so negative 6 pi over 7. I don't know where that is. So I need my pi to be my little placeholder, okay, which would be 7 pi over 7. Okay, so you could think of pi as a negative 7 pi over 7, right? Where would negative 6 pi over 7 fall? If we're going this way, would it be in quadrant? Yeah, it would be quadrant 3. He's right by that guy. It's right by pi. Not allowed to be there. Cosine's negative there. So I want to relocate to quadrant 2. I'm going to turn him into positive 6 pi over 7. That's going to put him into quadrant 2. Okay. All right, let's look at this dude. Okay. I don't have any of yours in quadrant 4. That's what I was looking for. Okay, so 7 pi of negative 7 pi over 10. I don't know where he is. Let's make our little placeholder. 10 pi over 10 is going to be pi. Okay, so negative 7 pi over 10 puts us in quadrant 3 again. We turn him into positive 7 pi over 10. He'll go to quadrant 2, which is exactly where we want him. Okay. Now, because Ish mentioned, what if it was quadrant 4? What if I had this? Okay. What if I actually had this guy on there too? Okay. Where is negative pi over 6? It's right here, right? You're in quadrant 4. Cosine's positive there. All students text constantly. So I want to relocate him to a positive quadrant that he's allowed to be in, which is 1. Okay. I'm just going to turn him into pi over 6. So cosine is super easy. You're either keeping the angles if they're positive, because they're going to be quadrant 1 or 2, or if they're negative, you make them positive because they're in quadrants 3 or 4, and it puts them back where they're supposed to be. That's it. Okay. All right, let's go back to F and G. Okay. So F and G have the opposite situations. Remember, they're the very black and white situations. You're either the value or you're undefined. End of story, right? So we're looking to see, are these two values between -1 and 1? If they are, the answer is that value. If they're not, the answer is undefined. So what's our answer going to be for F? That value. Our answer for G? Undefined, because it's so much larger than 1. And there we go. Okay. All right, is that one okay? The sign's not too bad. All right, let's go look at tangent then. Okay, let's look at his little graph. Remember, he's the little disco dude, right? He's a little disco dude that just repeats over and over and over. So he's a function, but he does not have an inverse. So I'm going to have to snip, 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 snip where I can and create him an inverse. So remember, I like to hang around here. All right. If I move over here one little scooch to the right, well, that's fantastic. There we go. That looks great. But I think I could go a little bigger. Well, I guess you could continue on to here because then you'd have this, and technically those two pieces would pass the horizontal line test, but they're two pieces and it has an undefined point included in it. And that's just kind of weird. So we're going to do what we did for sine, okay? And we're going to take an entire disco dude. We're going to go a little bit back and a little bit forward, and we're going to take the whole complete guy that goes through the origin. So if we do that, we're back to looking at negative pi over 2 to pi over 2, which means we're back in quadrants 1 and 4. So sine and tangent are over here on the side. Cosine is the crown. Okay, everybody got it? So now we're back to sine's restrictions. You had a little break with cosine, but now we're back. All right, so we have the explicit, we have the implicit where we just switch it around. We have our quadrants that we're looking at 1 and 4, but now look at our domain. This is new. With sine and cosine, we're restricted, right? -1 to 1. But disco dude, is he restricted? No, he's from negative infinity to positive infinity. So tangent here goes all real numbers for his range, which means his inverse is all real numbers for his domain. So inverse tangent can never be undefined. Okay, everybody see that? So that's new. We haven't dealt with that before. All right, let's throw some things in here. Okay, I'm gonna throw in a D also, by the way. I know you love that, but here we go. We're gonna throw in a D that looks like this. Okay. All right, so in addition to tangent being a little different, having that all real number domain, also remember tangent requires your brain to work a little bit more on the unit circle. The unit circle was built by sine and cosine. X's are the cosines, Y's are the sines. All you got to do is look and it's right there for you. Tangent's not on there. How do you find tangent? Y over X. So now your brain's going to have to work a little bit. In order to match these values, you're not just popping values right off. You're creating little ratios in your brain. Okay, if Y over X at that angle were put together and reduced or rationalized, would it come up with these values? So you got a little bit of algebra to do in your brain, okay, to get where we need to go. All right, so if this were inverse cosine of 1, I just find where X is 1. If this were inverse sine of 1, I just find where Y is 1. But now I'm inverse tangent of 1, which means I'm looking for the values on the unit circle. I guess I shouldn't use Y and X. I should use sine and cosine, but whatever you'd like to use here, okay? That will give you a ratio of one number over itself that reduces down to 1. Okay, keeping in mind, you're only allowed to be in quadrants 1 and 4. So you only have 9 possible choices, right? And they're over here on the side. So any ideas about which two values are exactly the same sign and everything, that will divide and just go down to 1? What'd you say, Ish? Yeah, square root of 2 over 2. Look right here. if I put square root of 2 over 2 divided by square root of 2 over 2, I'm going to get 1. So what angle is that? That is pi over 4. And that's my answer. Because at pi over 4, I've got root of 2 over 2 divided by root of 2 over 2. Those cancel out. There's your tangent. Okay. I kind of hesitated about using y over x because if we want to write it in that implicit and explicit form, it looks a little confusing. Okay. So what value of tan would give you, what angle would give you 1 as a value of tangent? Okay. So pi over 4, that's what we're dealing with. What if this were -1? What if it were the inverse tangent of -1? What would our answer be? Negative pi over 4, because we want negative root of 2 over 2 divided by root of 2 over 2. That's going to reduce down to -1. So negative pi over 4 would be the answer if it were -1. Okay. All right, let's skip down to C, and then we're going to come back to these two over here. Okay, so remember, now we're on 0. That's got to be a quadrantal, right? It's got to be one of these three, either this one, or this one. That's the only three I'm allowed to have, okay? Remembering this is sine over cosine, so it's the y over the x, okay? So if I want it to come out to 0, which one am I going to have here? Okay, I'm going to end up with a value of 0, right? Because I want the 0 on the top. 0 divided by anything is 0. Here, this would be 1 divided by 0. Nope. 0 divided by 1. That'll work. -1 divided by 0. Nope. So it's got to be 0. Okay. Are we all right with that? Okay. All right. Now let's look at these little weirdos over here because we got a root of 3 in here. Okay. If you have a root of 3, that means you're either dealing with root of 3 over 2 1/2 or 1/2 root of 3 over 2. Everybody agree with that? Because that's the only places you can get the root of 3's from. Now you have to figure out which one is going to go on top to get the value that you want. All right. It just so happens if all you have is square root of 3, you want the root of 3 to be in the numerator because the 2's cancel out. Okay. And that's just going to come with practice. So this one's a negative. So I'm going to be down here in quadrant 4, and I'm going to choose the one that has root of 3 over 2 in the y space. So instead of 5 pi over 3, I'm going to choose negative pi over 3. Okay, let's look at why that is. Why did I choose this guy? Well, this was his point. Okay, let's work that out and let's do the algebra with that. Okay, so if I do negative root of 3 over 2 divided by 1/2, because remember, tangent is y over x or sine over cosine. My 2's cancel, and I end up with negative root of 3 over 1, which is just negative root of 3. So that's where that came from. That's a little negative root of 3 right there. Okay, so this point with 1/2 comma negative root over 3 corresponds with negative pi over 3. And that's the answer to my inverse. Okay. Now, if they're the opposite, this is what you're going to end up with. Okay. This guy is actually going to be negative pi over 6. How do I know that? Because I've done a million of these. So you're going to know that too. Okay, let's switch our terms now. Let's say we have root of 3 over 2 comma negative 1/2. What does that look like when you put that as y over x? Okay, negative 1/2 divided by root of 3 over 2. Your 2's cancel. You get negative 1 over root of 3. But you know you can't leave it that way, right? You know you have to rationalize it. So then if I rationalize it, I'm going to end up with negative root of 3 over 3. And that's what I had here. So that means it's this one. Okay. So somehow in your little minds, try to come up with a way for you to remember if it's just root of 3, the root of 3 part has to go on the top. If it's got anything else in the bottom, it means it was rationalized. So the root of 3 originally was on the bottom. It was in the X spot. Here, the root of 3 was in the Y spot. Okay. And then because they're both negative, we're down there in quadrant 4, working through those. And then we already know what happens if it's root of 2 over 2. They go down to 1, right? Because they're the same value. So those are kind of your options there for tangent. Does that make sense? You have to figure out where you are, but it's that extra little step for tangent. Okay, you guys look thrilled. Okay, now let's try one in the calculator. All right, cosine doesn't have any in the calculator for you to do. But this one wants you to find the calculator or use it to find the value in radians. So make sure you're in radian mode. Okay. We want to round to 2 decimal places. We have inverse tan, that's just second tan, negative 0.3. Okay. And I came up with, why did it, okay. So I came up with negative 0.29. I wonder why I got a negative. Did you guys get a negative?
Yeah.
Okay. So I came up with negative 29. How many does it want? Just 0.29. I must have forgot my negative on my paper. Okay. All right. Okay, let's do some tangent composites. And then we're done with this section. Good gracious. And we can actually go on and do some other stuff. Okay. So tangent composites, let's just kind of go over what we have here. So again, they're going to cancel each other out. If tangent's on the inside, you're quadrant 1 and 4. If inverse is on the inside, you're all real numbers. So can you ever be undefined? Nope, never be undefined. Okay, so let's skip right over to B. On B, we have the inverse inside. So what's our answer going to be? It's just 80. It is just the value because remember, this just has to be between negative infinity and positive infinity, and it is. So we're good to go. It can never be anything that's not in there. So you're fine. Okay, let's try these 3. These 3 are where we need to kind of pay attention to what we're doing here. Okay, and we have to think about how we handled sine, and his little rules are over there on the board if we need them. Okay, so remember, you're in quadrant 1, we're good to go. We write it over. Okay, we're quadrant 2, we're going to do pi minus our angle. All right, if we're in quadrant 3, we're going to do our angle minus pi. But we have to be careful here because sine is positive in a different place that tangent was. So let's write our rules again, I guess. Quadrant 1 is good. Quadrant 2 is going to be pi minus our angle. Quadrant 3 is going to be our angle minus pi. And then you're not going to have it in quadrant 4, so you don't have to worry about it. Okay. All right, so let's look at these here. Where is tangent positive besides quadrant 1? 3. All students text constantly. So quadrant 3, it's positive, okay? So in quadrant 3, we're good to go once we do angle minus pi. In quadrant 2, we're going to need to make that guy a negative, okay? Because we want to put him down in quadrant 4 where tangent is negative. We have to think about where we're relocating these guys to. We want to relocate the angle in quadrant 2 to quadrant 4 where tangent is negative. If you're in quadrant 3, we want to relocate him to quadrant 1 where tangent is positive. That's the opposite for sine. Okay, here we go. So tan of pi over 3. What quadrant is pi over 3 in? 1. So we're good to go. We can leave him alone. All right. Let's look at this guy. 10 pi over 11. Well, if you already know where he is, that's great. If you're not so sure, let's make a little placeholder for pi. So if I turn pi into 11 pi over 11, where's 10 pi over 11? Quadrant 2. Okay, so if I'm in quadrant 2, I'm going to take pi minus my angle, and I'm going to make it negative. Because tangent is negative in quadrant 2, I'm relocating him to quadrant 4 where he's also negative. Okay. All right, let's look at this next one down here. Okay, tangent of 5 pi over 6. All right, if you're not sure where 5 pi over 6 is, make yourself a little placeholder out of pi. 6 pi over 6. That's going to put 5 pi over 6 again in quadrant 2. Okay, so quadrant 2, I do pi minus the angle. I get pi over 6, but because I'm trying to relocate him to quadrant 4, I make it negative, okay, because he was negative here. All right, so I'm not sure if you guys are bored or overwhelmed or confused or just tired or what, but hang in there. Please, please, we're not done. I'm squeezing in unit 7.2, so don't get excited and pack up. But please, please, please do your homework with this. Even if it takes you forever and you have to go through your notes for every single problem, do it. And I promise it's going to make this easier. If you don't get your homework done, it's going to be so overwhelming when it comes time for the next section. So you really want to get a handle on 7.1 with these inverses. I can't stress that enough. It'll just seem really insane, okay, if we wait too long. Okay, 7.2. So we're going to start it because we don't have class Friday. So we want to make sure we get some of this done out of the way. 7.2, at the end of it, we're going to hit the other 3 inverses, the secant, the cosecant, and the cotangent. The good news is we're going to take them and turn them into the inverse of sine, cosine, and tangent. So you don't have to learn anything new. We're just going to keep practicing what you've already learned, okay? But before we get there, we're going to have some composites. These composites aren't the function and its specific inverse, so they're not going to cancel out. These are mixes of everything, of all of them that you've learned. Okay, now I went ahead and put these in the front of this section because I thought, well, we've already been doing these, so it just kind of flows a little better to do it this way. But in your My Math Lab, it's actually the opposite. So there's 17 problems in section 7.2 homework. 12 through 17 are these guys. So it's kind of like I'm starting in the back of My Math Lab and moving forward, but I just think it will be a little easier for you if we stay on this roll here, okay? All right, so really all you're gonna need to be remembering here, cosine, quadrant 1 and 2, sine and tangent, inverse, quadrant 1 and 4. But our order of operations is gonna take over here. So even though it looks like it's going to be really hard, it's not, okay? You're going to treat these like parentheses. And if you think about, please excuse my dear Aunt Sally or PEMDAS, that first thing you have to do are the parentheses. So all you're going to do first is just these simple little problems, then take that answer and apply it to the outside problem. So they are really honestly not bad. Okay, so here we go. We're going to ignore the sign. We're going to ignore it. And we're simply going to look at inverse cosine root of 2 over 2. Okay, he falls within the domain of -1 to 1, so we're going to keep going. Cosine's the crown, so I have to be in quadrant 1 or 2. So remember, you only have 9 choices with these single inverse functions. So for quadrant 1 and 2, where is cosine equal to root of 2 over 2? Right here, pi over 4, which means this whole big thing is equal to pi over 4. Now I'm going to bring sine back in. So what now my second part of the problem is, what's the sine of pi over 4? Okay, I go to pi over 4. My sine is root of 2 over 2. That's my answer. Now this was a horrible coincidence that made it look like I popped it right out of the middle. That's not what I did. Okay, that was a terrible example, Ms. Holcomb. But anyway, we just do it in 2 different parts. Okay, let's skip example 2 and go to example 3. Okay, example 3. Here we go. I'm ignoring tangent. I'm looking inside. This is between -1 and 1. I'm good. Okay, sine has to be quadrant 1 and quadrant 4. Those are my only 2 choices. Okay, where is sine equal to root of 2 over 2? Pi over 4. Okay, this is pi over 4. Now I'm going to come back and put tangent in the front. What is the tangent of pi over 4? I go to pi over 4. Remember, tangent is sine over cosine. Good, I already heard 1, but you can put sine over cosine. These cancel. Your answer is 1. Okay, now let's squeeze example 2 in because it's weird. All right, I don't know about you guys, but when I see root of 2 over 2, I know I'm on the unit circle. Does -1 over 3 really sound unit circle-ish to you guys? No. Okay, so we got an issue here. I'm covering up cosine. I need the inverse sine of -1/3. Okay, notice what I did in every single situation is I found the angle based on that inverse. There's no angle to find here. It's not on the unit circle. So remember, when you get yourself in a pickle in trig, go Pythagorean. Okay, go Pythagorean. If you don't recognize it from the unit circle, do not worry about an angle. You're not going to find an angle. You're going to approach it from Pythagorean and then fill it in that way. So the inverse sine, remember, sine is sine, whether it's inverse or not. You have been given here, okay, -1 over 3, and for sine, that's y over r. Remember, that's not a reciprocal, that's a true inverse. Sine is always y over r, whether it's an inverse or not, okay? So I'm going to use this to find x. So x squared plus, okay, -1 squared equals 3 squared. My x squared is going to equal 8 because that's 9 minus 1. My x is going to be plus or minus 2 root of 2 when I reduce it. Now I have to figure out, is x positive or negative? This is the key. You know you are only allowed to be in quadrant 1 or quadrant 4 with sine. Okay? So if it's negative, what quadrant am I in? I'm in quadrant 4. And in quadrant 4, is x negative? No. So my x is a positive 2 root of 2. Okay. Now I want the cosine of this. So cosine is equal to x over r. So I put my x, I put my r, and there's my answer. Okay. So it gets a little complicated if you don't recognize him from the unit circle. You're going to have to go Pythagorean. You're not interested in an angle. You're just x, y, and r. Say that again. Why was it 2 root of 2? Yeah, why was it positive? Oh, why was it positive? Okay, so it could have been either one. think of it this way, Daisy. So this is fine. You know the negative can't go with the R. So the negative had to go with the Y, right? So we're down here. And with sign, we're only allowed to be in this one or this one. So a negative Y is going to put you down here. And then your X has to be positive because it's positive down there. Okay, does that make sense? Okay. All right. You guys have a great weekend. Let me see. Where is my recording?